Good morning and welcome to the video for Monday, January the 11th. This is going to be a video for fourth grade. We are to the chapter review. And so what I'm going to do is kind of briefly talk about some of the strategies that we've used as they relate to the problems I'm going to ask you to do. Now, I'm not asking you to do the entire chapter review today. We're going to work on the first 3 pages today. We're going to work on the final 3 pages on Wednesday. And then we will be doing some more review in class on Thursday and Friday before we do an actual test sometime next week. Now, of course, we'll be out Monday because of Martin Luther King Jr. Day. And so that will kind of possibly necessitate maybe needing to do a little bit more review on Tuesday before I test you guys on Wednesday. So we'll kind of see how that plays out. If everybody's good after we talk through things on Thursday, we might even do it before the end of the week, just so you guys can get a chance to get this over with so we can move on to something else sort of and also keep kind of backtracking to review this because we've stretched this chapter out for an awfully long time. So I think some of you are starting to get it, and those of you that still need more practice, hopefully after seeing this, you understand what we can be working on to continue practicing this, but we need to keep kind of moving the train along as we get closer to the possibility of doing state testing here in a couple months. So we still have roughly half of a book to go, plus review work. So we will see this whole idea again. So let's start with the most obvious thing. What are we doing when we are working with fractions? One of the biggest things that we need to do is to be able to identify whether two fractions are worth the same amount, or if we get a fraction, try to figure out how to make it into a fraction that is an equivalent and has the same amount. So let's take a look at what I've drawn up here on the screen. This is actually going to mirror the fractions that we get for number 5. So I'm actually going to be helping you with one of the homework problems by giving you an example. Or using this as one of my examples. So let's say that I want to go ahead and compare 1/2 to 3/4. So to start with, I've got two different options. One of them is to go ahead and work with our multiplication or division strategy. So if I want to figure out what 1/2 would be, where's my cursor? There it is. Compared to 3/4, I can go ahead and start by doing this. And I'm going to go ahead and draw in my multiplication symbols here. And then I need to multiply by a number that's going to get me from 2 up to 4 when I'm done. So the goal is to get a 4 down here so that I can do my comparison. And so think about how many times we would count by 2 to get to 4. That should be 2. And again, this was the part that we were working on before break. And so some of us have the idea now. Some of us were still kind of struggling on this and our multiplication facts. So hopefully this will be a good incentive to kind of get in gear with practicing that, because by this time that we're doing this, we should be comfortable enough with our multiplication facts to be able to work through these relatively quickly. And it's more about doing the process than finding the answer to 2 times 2 or whatever numbers that we're working with. So the next step, once I figure out how many times I can count by 2 to get to 4, I need to multiply the top number by the exact same number. So whatever I do to the bottom part of the fraction, I have to do to the top part. And so that's the part that with the process that some of us kind of get a little stumped on. And so 1 times 2 would give us 2. So 2/4 is going to be our fraction that is worth the same amount as 1/2. Now, if I want to go back the other way, I can divide. And so I'm going to do that down here. So I'm going to start with 2/4 this time. And we are going to work our way backward to get something over 2. So if I started with 2/4 and I want to know exactly what my equivalent or reduced fraction would be, then I'm going to figure out what number I can divide 4 by to get to 2. And then that is going to be the number that I would divide my top and bottom number by. And so in this case, we would be able to do 4 divided by 2 and 2 divided by 2. Now, I mentioned something, but then I think I may have said this incorrectly. When we're reducing a fraction, we want to figure out a number that we can divide into both of those numbers. So in this case, because they're both even numbers, it would be 2. We could possibly work with larger numbers, but 2 will always work. And then if we get an answer that we can reduce again, we can always do it a second time, and there's nothing wrong with that. So here would be the way that we get from 2/4 and reduce that fraction to 1/2. Now, this is one way to do this. The other way that we can do this and find equivalent fractions is using either a fraction strip or a number line. So I have some lovely, not very neat, but functional number lines that we can use. So this is going to be 0 over here, and then 1 is going to be over here for both of these. And so I've got one that's broken up into thirds for reasons that will become apparent when we look at number 2. And so 1/2, I could go ahead and say that that part would be right here. And then I can also use this and say that that would be 1, 2 parts out of 4. So I could also use that. And then if I want to compare, let's say I want to do 2/3 and 2/4, and I want to compare those two fractions. I can go ahead and use this to do that comparison. So on the problem number 1, we're just figuring out whether the two fractions are equivalent. So in most cases, we are actually going to be seeing if we can go ahead and, like, for instance, go from 4 up to 16. Can I multiply a number by 4 and get up to 16? And if so, can I multiply by the same number and get from 1 up to 4? That might not be the easiest way to explain it, but that's kind of what we're doing. And that might be partially my fault if somebody's still confused on that. So hopefully, if you're watching this, you have your parents, they may have a different way to explain it to you that might make more sense to you. So ask them, like, show them this video and say, hey, this is what my teacher's telling me. Is there another way that you can explain this to me so that I can understand? Because it's one thing for me to show you and talk you through it, but another for me to choose the perfect words that is going to make this idea click inside your head. So I've tried to do that over the last few weeks, but if you're still struggling with that, please let me know, or please ask your parents to sit down and watch this with you and see if they can find a way to explain it that works for you. Okay. So that's all we're doing for number 1. We can go from our smaller fraction, see if we can multiply to get to by a number to get to what the larger number fraction would be, to see if they're equivalent or not. For number 2, we need to put the order of the ingredients from least to greatest. So I actually have 2 different number lines. I have one with fourths, and then I have one with thirds. So you could actually make a similar picture to help you with that. For number 4, we are looking to figure out whether or not any of these fractions are less than 1/2, equal to 1/2, or greater than 1/2. You will notice that you have 3 boxes for each of these. You're only going to use each thing one time. So we are not going to fill up all 9 of these spaces. And it's entirely possible that we are not even going to fill up 3 on any of these categories. We only have 6 options. Okay, so they just gave it to you like this to give you options just in case. It doesn't mean that we're going to have all 9 boxes filled in. I say that because I've actually watched people try to do that. So we're only using them once. It only works one time. So how do we find this out? So let's look at the fraction for 11/16. The idea is to take 16 and we can divide it by 2. So think about how many times you can count by 2 to get to 16. That is going to give us the number that is half of 16. Once you know the number that is half of 16, then we can figure out how that compares to our top number. Now, in some cases, we'll end up with something like I mentioned where, let's say we are working with a fraction over 7. We're going to get like 3.5 is going to be half of 7. So in this case, we have all even numbers for our denominators, so it's going to work out perfectly. We can divide everything by 2, figure out how many times we can count by 2 to get to that number, and then compare our top number to the number of times we can count by 2 to get to the denominator. And then if we do that, we can figure out whether our number of parts that we're counting is going to be less than, equal to, or greater than 1/2 of the whole. And I didn't mean to drag that. Let's go up to our next part. You can actually use the picture that I drew further back to answer number 5 as well. So in talking about that problem, if you looked at the picture and what 1/2 was equal to, that being 2/4, how would we compare that to 3/4? I drew a red line through here. And again, given the opportunity, people might accidentally do something wrong. So one of our sides is going to have 1/2. The other side is going to have 3/4. And we want to put the smaller of the two fractions in this side, and we want the larger of the two fractions on this side. I have had people just decide that, hey, I'm going to put a 3 here, and I'm going to put a 2 here, and a 1 here, and a 4 here. So hopefully this makes sense. 1/2 is going to be the answer for one of these two sides. The 3/4 is the other fraction that is going to be for the other side. Okay. Let's talk about number 6. I'm going to take a quick sip of water. So Brad has been practicing the piano. Words are hard. He spends a quarter of an hour practicing scales and a third of an hour practicing the song for his recital. And we want to figure out which ones of these statements are true or not. So we're saying, is this a true statement? Yes, it's true. No, it's not true. And so you're going to have to figure out what a common denominator for 4 and 3 is. We can find that by multiplying those two numbers together. And then we can go ahead and find our equivalent fractions for parts out of whatever our common denominator would be. Hint, since 6a is saying 12 is common denominator, and then the other two things are giving you parts over 12, that might give you a suggestion about whether part A is correct or not. They're probably not going to do this to you on the other two if that first one were not. Just a thought. So we want to figure out what the two equivalent fractions would be with parts over this number, and I'm more concerned about these two parts than I am with this one. So number 7, we want to find simplest form. So we want to figure out what number we can divide by using 4 and 24. So they're both even numbers. I gave you a suggestion earlier about what we could do to start with. When we have our simplest form, we have the smallest number on the top and bottom that we can possibly get. We cannot divide any further. And then I'm also going to ask you to do, oh, that's right. Oh, never mind. No, this is fine. So we're going to do more practice. Again, we have a smaller fraction and a larger fraction. Go ahead and use the multiplication strategy to see what number we can multiply by. So for instance, how many times can I count by 4 to get to 28? Or can I even do that? And so that will give you some suggestions. And then if I can count by 4s to get to 28, how many times? That's going to be the number of times that I multiply this number by. And then the last part would be when I do that, do I actually get this number? If I get something different, then that's not going to work. It's not going to be equivalent. I am crossing through number 9. I believe I mentioned that. Yeah, so we're dropping number 9. We're dropping number 10. Number 10 is really long. The first step is really easy. Some people get confused on the second step. So if I decide to give you a problem that looks like this when we do the actual chapter test, it will probably be this part. And I will remind you how that should work. And I do want you to do number 11. So we have 3 different fractions. We want to find simplest form for all 3 of those fractions. So that's all they're asking for. We don't have to do anything else. So let's see, we have 10/28 for cat. If we reduce that, is this going to be the smallest fraction we can get? If not, then the answer would be false. If it is the smallest fraction, it will be true. So we're going to do that 3 times 1 for each of those fractions in the problem. So if you have any questions, please feel free to ask in Google Classroom. Again, this would be a great idea, a great time. If you haven't been working along with your parents at home, to talk with them. It's okay if they watch this and they don't understand what I'm talking about either. We can figure out something. I can pull you in on a conference call and we can talk and work through some examples and kind of jog your memory about how this is supposed to work. Now, some of this is similar to what we most recently did last week, so you could go back and watch those lesson videos for 6.6, 6.7, and 6.8 and see if anything with that in a way that I explained one of those problems helps you figure out what we're doing with these, okay? So we've got plenty of time. There's no race to get this done. We're going to do a few more pages of this on Wednesday. So if you have any questions, please feel free to ask in Google Classroom. Hope you have a great day, and I will see you tomorrow.